the first problem is an example of the easy kind of factoring that we have when the quadratic starts off with an x squared term, which we do here. So, so I know all that I'm looking for is two numbers whose product is positive 25 and whose sum is negative 10. So that's my goal. The numbers are going to be minus 5 and minus 5, so the same number twice. And again, if you had recognized this as a form of a perfect square, you'd be right, but the fact that we have the same number twice here tells us that, so we don't have to know ahead of time what that form is. We should be able to see it when it happens, and so that just means that the factoring will be x minus 5 times x minus 5. You should always check, but in this case, if you do FOIL with this, you'll find out that that is the correct answer. In the second problem, this actually is a perfect square on the left side, so you can do this by factoring, but remember we said that we have the square root method that's really a shortcut if you happen to notice that the variable is tied up inside of a perfect square. It doesn't matter what it is squared, as long as it's something squared equals a number, then I'll be able to say that the stuff in parentheses is either the square root of the number, so in this case the square root of 16 is 4, or the stuff inside the parentheses is negative square root of the number. So in either case, if 8w is 4 or 8w is negative 4, when you square 8w, you'll get 16. And so this gives me my two equations to solve, so I'll have w as a half by dividing both sides by 8 for this one, and I could have w is negative 1/2 by dividing both sides by 8 for this one. So my solution set is 1/2, negative 1/2. This last problem on the first page looks like it's going to be difficult to factor, and so we don't really know, what we're getting into. So you never know how much time you want to really spend trying to factor these things, but let's just take a second to see if we can see how it's going to factor. The one thing we do have going for us is that 11 is a prime number, so the only way you could have an 11x squared as your first times first is to have an 11x times an x. So that's a big help to know that if it's going to factor, it has to factor in that way. The only two possible ways to get a product of negative 9 is to have, well, I guess there's three ways. There's 1 times negative 9, 3 times negative 3, or negative 1 times 9. And so we can try each one of these. There's only 3 things to try, so although I guess 4 if you try the plus 3 and the minus 3 both ways that they could go here. And so if you try them, you'll see that you're not going to find anything that works. And so if we, and you may have given up before this just because the numbers look bad, but in this case, the quadratic formula is going to be our best chance of getting an answer here. Make sure you check before you use the quadratic formula that your equation really is written in the form ax squared plus bx plus c equals 0. If it doesn't have that form, then the quadratic formula will not be right. So you can't just go right to that form and just invent what a, b, and c stand for. You must write it in that form first. So in this case, we already have that. So the quadratic formula says it's negative of the b term, so negative 3 is plus 3, then plus or minus the square root. B squared here is 9, and then I have 4 times a times c. So you can see that that's already getting to be a pretty big number, divided by 2a, so divided by 22. So I need to know what this number is under the square root sign. You can see it's going to be positive because it's negative 4 and a negative 9. So at least we know that that we are going to have real solutions here. It's not going to be no solution, but I need to figure out what that number is. And if I use a calculator, I'll find out that the number under the square root sign is 405. And of course the denominator is still 22. Now 405 is not a perfect square, so I can't really do anything with that, but if I wanted to see if this possibly could be simplified some, I can at least see if that square root of 405 can be rewritten. And if you try factoring it, And here you can tell a 5 divides evenly into this, so you might just ask yourself, 5 times what is 405? You would discover that 405 is actually 81 times 5. And of course, the square root of 81 is a nice number. So this is really square root of 81 times the square root of 5. So 9 times the square root of 5. So we could at least write this square root of 405 term as 9 times the square root of 5. Those are the same thing. In this case, that doesn't really make the problem simplify anymore, because there's not going to be a common factor in the numerator that I can cancel with a factor in the denominator. So it's interesting to know, something should be checked to know that the square root of 405 is 9 times the square root of 5. But in this case, it doesn't actually help you reduce the problem at all. So on the next page, we have a question where we want to know about the possible x-coordinates. So this is another one of those questions where we're really trying to get at, do you know what the connection is between the coordinates of a point and the inputs and outputs into the equation, into the expression for the function. This is an output. That's not how you spell output. So this formula is outputs, right? The input is what you put in for x. The output is what this expression gives you, right? That's the x coordinate is the input. The y coordinate is the output. It comes from that expression. So if you want to know when the output is 4, that means you want to know when the thing that comes out of the function is equal to 4. And you can see that there should be 2 values of x, possibly 2 values of x. That will make this happen, but we have to solve the equation to find out what they are. So I can subtract 4 from both sides. This is an easy problem to factor. It's got a 1 in front of the x squared, so I need 2 numbers whose product is negative 54. The product should be this, and the sum should be that. But there aren't that many ways to get a product of negative 54. One of the ways to get a product of negative 54, I'm sorry, it should be positive 54. One of the ways to get a product of positive 54 is 6 times 9, and 6 plus 9 is 15. I do want this to be a negative sum, so I want negative 6 times negative 9. So x minus 6 times x minus 9 is the correct factorization. Again, don't just assume that that's right. Do FOIL to check, and if you do, you'll find that that is correct. So either x minus 6 is 0, or x minus 9 is 0. And so that means either x is 6, or x is 9. So the x-coordinates, possible x-coordinates are 6 and 9. It asks for what the x-coordinates are and those we get. So that means the point 6, 4 is on the graph, and the point 9, 4 is on the graph. And that's really easy to check. In this problem, again, we're just trying to get the function notation right. F of 0 means y coordinate when the x is 0. So what y coordinate corresponds to an x coordinate of 0. Remember, the number that goes into the parentheses that you're substituting in is the x coordinate. The answer, the output, is the y coordinate. So on the graph, this point right here has coordinate 0, 1, and because this is an input-output pair, the input's the first coordinate, output's the second coordinate. That's always true. So the y coordinate, the output, when the input is 0, is 1.